Hello, my algebra friends. We're here to talk about section 8.3 in your algebra journal. So now we're going to be looking at the roots of a quadratic function. So post haste, let's get started. Okay, so as you can see, we're going to be graphing fx equals ax squared plus bx plus c. How do you find the vertex of the graph of y f of x equals ax squared plus b? So our first idea here is let's go ahead and sketch these graphs of y equals 2x squared minus 8x and y equals 2x squared minus 8x plus 6. So basically these two graphs are going to be exactly the same except for this plus 6. So you might want to think about to yourself, how are these two graphs going to be different? Okay, so I've gone ahead and I've graphed them on Desmos. As you can see, I also took the time to label all the requisite parts here. So you're going to notice here we have the intercept at 0, 0 for the red curve, which happens to be 2x squared minus 8x. Right over here, we have the intercept of that red curve again, 4, 0. And down over here, here's the vertex 2, negative 8. For the blue curve, we got vertices at 1, 0 and 3, 0. And the vertex at 2, negative 2. So right now you might want to take a look at the vertex and notice that they both have the same x coordinate. Also notice that the y coordinate, while it's not the same, the y coordinate for the blue curve is up 6 units from the red curve. And why is that important? It's important because you'll notice on the blue curve, we have that plus 6 right here. So do you think that's important, that the vertex goes up 6 and then the equation also has a plus 6? I think it's probably important. So coming back over here, we're going to go ahead and graph them. Now I honestly have forgotten where all of those are. I'm pretty sure this is 0, 0 over here. And let's go back to the curve. 0, 0, 4, 0, and 2, negative 8. 0, 0, 4, 0, and 2, negative 8. So here's our first parabola. Okay, not nearly as nice as the one that you saw on Desmos, right? The next one, I think we had vertices. No, we definitely, this was at negative 2, negative 2. I shouldn't say definitely. I'm going to eat my words, I'm sure. Yeah, negative 2, negative 2. 2, negative 2, I'm sorry. 1, 0, and 3, 0. So 1, 0, and 3, 0, which are kind of here and here, okay? Okay. Well, apparently I did something wrong because we were supposed to put the other one on that one. Sorry about that. I got excited, wanted to put them on the same curve. Okay, so we've graphed them. What do you notice about the x-coordinate of the vertex of each graph? Well, the x-coordinate is up 6 units in the second graph. And we should say the second red graph. Okay, so there we go. There's that 6 units. That plus 6 has been highlighted already. So now you see where that 6 comes in and why it's important. And so now we're going to use a graph of y equals 2x minus 2x squared minus 8x to find the vertex. Verify your answers by solving. So we don't have to graph, we don't have to look at that. We already know that the vertices are at 0. And what do we say, 4? Let's verify by solving that. And solving that means going through the analytic algebra. So let's see, we're going to factor this, and there's only 2 terms, So that makes things easier for me. I also noticed that there is, pointing the wrong way, there's also both terms have an x, so I can just use my undistributing rule here. So they both have an x. The greatest common factor of 2 and 8 is 2, which is another way of saying that 2 will divide into 2, and 2 will also divide into 8. So I'm going to factor out a 2x, and if I divide this by 2x, I get an x, and if I divide this by 2x, I get 4. And then we're going to do our quick maths. I forgot that we were saying that in class. Quick maths, x would be equal to 0 and x would be equal to positive 4, which coincidentally is the same thing we got from the graph. So which is better, the graph or the analytics? Well, that's kind of up to you. So compare the value of the vertex and the x-coordinate of the vertex and the values of the intercept. So the vertex was x equals 2, and the x-intercepts, they were 0 and 4. So what do we notice if we graph those on a number line? Well, this would be 0, this would be 2, and this would be 4. They would be equally spaced, and this is exactly at the center. Okay, so the vertex is the middle, or it's at the middle of the x-intercepts. Once you realize that the vertex is always right smack in the middle of the x-intercepts, then math actually gets a lot easier. That's the pattern that we're supposed to be looking for. The vertex is always between the two x-intercepts. That's next level thinking. Okay, so we're supposed to solve this by factoring. I actually did a little bit of work ahead of time. So we got x equals, we're going to factor out that x, and you get ax plus b. And then we're going to take a look with our quick maths, and x equals 0, and x equals negative b over a. So that's that quick maths that we were talking about in class, negative b over a. Remember, negative because there's a plus sign in between those two terms, b over a because it's the constant term over the coefficient of the linear term. So b over a, constant over linear coefficients. So then you might ask, what are the x-intercepts of the graph of ax squared plus bx? We already did that. We did the quick maths over there. No, over there. We've got 0, and we've got negative b over 2a. These are our x-intercepts. Remember, we're also calling those roots. So we're going to complete the table to verify our answer. So if these really are the roots, then when I substitute them into the function, I should get a 0. Roots are places where the x-coordinate is equal to 0. So we did the first one. I've done some preliminary maths. So a 0 squared is 0. A times 0 is 0. B times 0 is 0. So yeah, that's a 0. How about the second one? This is definitely the more difficult of the two. We've got a negative b over a squared. Well, the negative times a negative is a positive. B times b is b squared. A times a is a squared. So I get a b squared over a squared. Over here I get negative because of this negative sign over here. We can do this backwards. So we got minus b times b is b squared, and well, the a just sticks on the denominator. So we've got one more step before we're finished solving. Since this has an a on the numerator and the denominator, we can cancel them out, and then you're left with b squared over a minus b squared over a. That is 0. So we have confirmed that the roots, which are the x-intercepts, those are x equals 0 and x equals negative b over 2a. So now we're going to use some deductive reasoning. The x-intercepts are 0 and negative b over 2a. So the vertex has to happen halfway between the roots. Okay, so what's halfway between 0 and negative b over 2a? Well, one way to do that is to find the average. So one way to find the way to find the average is to add everything together. So 0 plus negative b over 2a, and then divide everything by 2. How much is this, you might ask? Well, negative, it's not 2a. I was jumping ahead of myself. Negative b over a, and then divide by 2. So what is that? Well, I let the cat out of the bag. That's negative b over 2a. Negative b over 2a, halfway between the roots. So the vertices of these two curves have the same x-coordinate. If the a is the same, if the b is the same, then they have the same x-coordinate of the vertex. The y-coordinate might be different, but the x-coordinate is going to be the same. So the vertex occurs when x equals, and here's that same quantity, negative b over 2a. Now in the last 2 minutes, I've said negative b over 2a maybe like half a dozen times. So do you think negative b over 2a is an important thing to memorize? You bet. Incredibly important. Negative b over 2a. That is super important. Communicate your answer. How can you find the vertex? Well, the x-coordinate is negative b over 2a, and this looks like a super complicated equation, but really, once you find the x-coordinate of the vertex, you're just going to substitute it into the equation. I'll show you what that means. So the first one we're going to do here is this. Now in class, I usually tell my students to tell me the values of a, b, and c. Tell me what you want, what you really, really want. A is 1. It's invisible, silent. B is negative 4. C is 3. The vertex happens when x equals negative b over 2a, which is negative of negative 4 over 2 times 1. So let's do some maths here. If you want to grab your calculator, you can go ahead and do that. I'm going to use the old noggin. So negative 4 divided by 2 is negative 2. The opposite of negative 2 is positive 2. Okay, so that's the x-coordinate of the vertex. To find the y-coordinate, I'm just going to do f of 2. Basically, I'm taking this number here, and I'm substituting it into the equation. So what is f of 2? That's 2 squared minus 4 times 2 plus 3. And to show you that again, I'm taking this 2 and I'm putting it into the equation for the y-coordinate. Okay, let's see, 2 times 2 is 4. 4 times 2 is 8. 3. 4 minus 8, that's negative 4. Negative 4 plus 3, negative 1. Now the y-coordinate is negative 1, so the vertex is 2, negative 1. Take a minute and graph this into, pause the video, graph this in your Desmos, and let's see if we get the same result with the vertex at 2, negative 1. Okay, hopefully you had enough time to pause it there. And here is a Desmos. Look at that. Let's figure out our coordinate. Actually, let's just go all the way around. There's the y-intercept at 0, 3. Here's the root, 1, 0, 3, 0. We don't have a way of getting those yet. And then here is our vertex, 2, negative 1, just like we predicted. Dun, dun, dun. Okay, now that we can find our vertex reliably, y, or the x coordinate equals negative b over 2a. Such an important, I mean, that's so important. I'm going to go ahead and I'm going to highlight that again in blue. Look how crazy that is. Yellow and blue make green, right? That's how important that is. Okay, so in our own words, what is the minimum value? The minimum value is the lowest point in a parabola that opens upwards. Opens upwards means it looks like a U. What is, I put that in the wrong place. That's the minimum value. What is the maximum value? Well, the highest value is just the highest point in the parabola that opens downward. Okay, so depending on whether your parabola opens up or down, you'll either have a highest or lowest point. Now, the parabola won't, if parabola has the highest point, it won't have a lowest point. It'll just keep going down. Likewise, if parabola has a minimum value, it'll just keep going upwards. So no need to worry about, a parabola is either going to have a highest point or a lowest point, never both. All right, here's stuff that we've gone over. You can read these, of course. Y-intercept is C. That's a good one. The y-intercept is C. The x-coordinate is negative b over 2a. And then the axis of symmetry, we didn't talk about that. The axis of symmetry is always the same x-coordinate as the vertex. So since the x-coordinate of the vertex is negative b over 2a, the axis of symmetry is also going to be negative b over 2a. So I think it's time for a couple of, here we got minimum values and maximum values. So let's do a couple of examples here. First one, how about this? We'll find the axis of symmetry and the vertex. We'll only do a couple of these. So we'll do this first one, number 1, and then we'll go on to number 4, which looks a little more hellacious. So number 1, let's find the axis of symmetry. The axis of symmetry happens when x equals negative b over 2a, the most important thing we've learned today. So what is negative b over 2a? Well, how about we write down a is 1, right there. B is equal to negative 10, right there. C is equal to 2, right there. Right there. Okay. The axis of symmetry is x equals negative b, negative of negative 10 over 2 times 1. We'll do the maths. Negative 10 divided by 2 is negative 5. The opposite of negative 5 is positive 5. Okay. Next, let's find the y-coordinate of the vertex. That's going to be f of 5. So that is 5 squared minus 10 times 5 plus 2, which is equal to, let's see, 5 times 5 is 25. 5 times 10 is 50 plus 2. Computer, how much is 25 minus 50 plus 2?
25 minus 50 plus 2 is minus 23.
Minus 23. Okay, there is our x-coordinate here, our y-coordinate here. Our vertex is at 5, negative 23. I don't recommend you graph that on paper. It's going to be way, way, way at the bottom of your paper. Question 4. Same idea. What is A?
These definitions are towards, directed at, intended to belong
Computer,
to.
stop. She just turns on automatically. I don't know. A is negative 3. B is 6. C is 1. Let's give ourselves some room. All right. Axis of symmetry. X is equal to negative of b over 2a, which is a negative of 6 over 2 times negative 3. Okay, 6, fine, nothing to do there. 2 times negative 3 is negative 6. 6 divided by 6 is negative 1, and then the opposite of negative 1 is positive 1. Okay, the y-coordinate is equal to f of 1, which is negative 3 times 1 squared plus 6 times 1 plus 1. Okay, do all the multiplication, which in our case means here we're going to 1 square is 1, negative 3 times 1, or you might want to think about that as negative 3 times 1 times 1. That might be easiest for us. Negative 3 times 1 times 1, that is what? Negative 3. Yeah. 6 times 1 is 6. Negative 3 plus 6 is negative 3. No, negative 3 plus 6 is positive 3. Positive 3 plus 1 is positive 4. So we have our vertex, so our axis of symmetry is x equals 1, and our vertex is 1, 4. Sweet. And are we? No, we're not. Graph the function, describe the domain and range. Let's do this one first. A equals 3. B equals 6, C equals 2. First of all, let's find the vertex and the axis of symmetry. So the axis of symmetry is x equals negative b over 2a, which means x equals opposite of 6 over 2 times 3, which is opposite of 6 over 6, which is negative 1. So there's our axis of symmetry, x equals negative 1. Okay. Let's get a coordinate axis. Magic. We got ourselves a coordinate axis. Let's draw our axis of symmetry. I think I'm going to choose to do that in red. That's going to happen when x equals 1. Here we go. Axis of symmetry. We know the vertex is going to be along that axis. Second thing we know is that since a is 3 and it's positive, that means our parabola is going to open upwards, right? Okay, that's going to help. Next thing we know that because that c equals 2, we know that the x-intercept is going to be 2. So we got that point right there at 0, 2. Always. Now it's time to find the actual vertex. So the vertex happens when I substitute negative 1 into the function. So the y-coordinate, and let's give ourselves a little bit of room. So the y-coordinate is going to be equal to f of negative 1, which is equal to negative 1 squared plus 6 over times negative 1 plus 2. Just kidding. 3 times negative 1 squared plus 6 times negative 1 plus 2. Let's think. What is 3 times negative 1 times negative 1? Now that's something that I would normally just think about. I wouldn't actually write that down, but since you can't see inside my noggin, I'm going to have to write that down for you. So 3 times negative 1 is negative 3. Negative 3 times negative 1 is positive 3. 6 times negative 1 is negative 6 plus 2. Let's see, 3 plus negative 6 is negative 3. Negative 3 plus 2, negative 1. So that means I have my vertex over at negative 1, negative 1, negative 1. Negative 1, negative 1. The next thing I'm going to do is, let's see, I know that this is not something that you guys talked about in the packet so far, but I know that this parabola is symmetric about the axis of symmetry. So if I go over 1 and then up 3 to get to this point, that means I can go over to the left 1 and also go up 3 to get this point over here. Notice how it's mirrored around that red axis of symmetry. Super important points, things for us to think about. Now that I've got those, I can go ahead and start making my parabola. Try to do this carefully so it doesn't look so messy. I've drawn some horrible parabolas for you guys, and I want to at least give you one nice looking one. All right, there we go. All right, so maybe not great looking, but definitely better than what I've been doing lately. I think it's important for us to draw an arrow at the end of here to indicate that the parabola keeps on going up and up. Now, domain and range, this is the first time we've seen them. Domain for every parabola is always negative infinity is less than x is less than positive infinity. Basically, all real numbers. Now, you might say that real number is kind of redundant, but believe me, it's not. Once we get to other higher maths, real numbers actually has a meaning. How about the range? So that's the y-coordinate. So the lowest y-coordinate, remember we're opening upwards, so our parabola has a lowest point, and our lowest point is -1. So our range is the y-coordinates need to be greater than or equal to -1. So that's how we're going to describe our domain and range. We're running long here at 26 minutes. So let's see, do you think this one has a minimum point or a maximum point? Well, this parabola opens downward because it's negative, so this has a maximum. How about this one? A is greater than 0, so this one has a minimum. I'll leave it to you to find out where that minimum is. Hint, negative b over 2a. And then here, the last point, we've got the height of a rocket. The rocket explodes when we get to the highest point. So when does the rocket explode? I don't know. It's a quadratic function. So let's use what we were doing before with finding the vertex. So let's take a minute here. I'm going to pause it. Find the vertex. Hint, negative b over 2a. Did you find the axis of symmetry? And was that axis of symmetry 7.8125? Pause it again, and let's find the coordinates. Okay, the rocket exploded when t equals 7.8125 from our equation over here. That happens when, that is the time when h is at a maximum. 7.8125. And at what height does the rocket explode? Well, the rocket explodes at, well, you just substitute now. Substitute 7.8125 into your equation, and you get 976.5625. And I think that's in feet. It's important for us to note that. Feet. Time is in seconds. So there it is, everyone. We're finished with our journal. Hopefully you guys have learned something really interesting. And if you didn't, I hope you at least learned negative b over 2a, the most important part of the parabola that we're looking at today. All right, have a good one and see you next time.